Alright, welcome again in another tutorial of the topic differentiation. In this tutorial we continue with the derivative of quotient of polynomials, whereby we are going to solve that example which will make application of that subtopic, the derivative of quotient of polynomials. This example says if y equals to 1 over the square root of 1 plus t squared, and x equals to t over the square root of 1 plus t squared, prove that dy dx equals to negative t. Look, y is a function of t, and x is a function of t. But the question is talking about dy dx. You would have expected y to be a function of x, but that's not the case. So when you encounter this kind of question, don't give up. It is possible to solve this question. See, from this one y, I can obtain dy dt. And from this one x, I can obtain the x dt. So I am looking now for dy dx. Dy dx will simply be obtained by taking dy dt times dt dx. Okay, so you can see dt na dt kama zinakufa. It's just like a chain rule. Okay, but anyway, the point is it is true. If I take dy dt times dt dx, I get dy dx. Okay, dt na dt as if. Okay, there's another explanation. I will come to derive the chain rule and upload a video for that. So we are going to ask, that's how I obtain dy dx, but this is the t dx, this is not the x dt. Well, I'll show you as I solve this question how to obtain the t dx from the x dt. So from this one, y equals to 1 over the square root of 1 plus t squared, I can obtain dy dt. So this is a quotient. I'm going to use a quotient rule, so I'll let u equals to 1, and I'm going to let v is just equal to the square root of 1 plus t squared. So du dt, okay, so I know the quotient rule is just dy dx is equal to v du dt minus u dv dt over v squared. So I have u and v, but I don't have du dt and dv dt. Du dt can just be obtained from u equals to 1. It's just going to be 0. What about dv dt? Okay, so I have v. Is just equal to the square root of 1 plus t squared. So, this is a composite function. In order to get the derivative of v with respect, the differential coefficient of v with respect to t, I'm going to use a chain rule. I'm going to let 1 plus t squared is equal to w. Okay? This is what I'm going to do. So after that, I will use the chain rule to find dv dt. It's just dv dw times dw dt. So the w dt can be obtained here. I have w is just equal to 1 plus t squared. This is plus. So the w dt now, if I differentiate 1, I get 0. If I differentiate t squared, I get 2t. So it's just 2t. This is the w dt. And then now from v equals to the square root of w, I can get dv dw. So dv dw will just be equal to 1 over 2 the square root of w. So dv dw, so it's just going to be equal to 1 over 2 times w. W is just 1 plus t squared. So now my dv dt from chain rule is just going to be equal to dv dw, which is this one, 1 over 2. This one is 1 plus t squared times dw dt, which is just 2t. 2t. So the 2 and 2, they go away. So this is dv dt, t over 1 plus t squared. So I had my y. My y was 1 over 1 plus t squared. So I said I'll do this, I'll find dy dt by using the quotient rule, which is just v du dt minus u dv dt over v squared. So my v was just this one, 1 plus t squared, and my u was just 1. I already did this, and my dv dt was just t over, this was 1 plus t squared, the square root, while my du dt was just 0. So dy dt now, by using this quotient rule, is just going to be equal to v. V is this one, 1 plus t squared times 0 minus, du dt is 0, minus u is just 1 times, this one is t over the square root of 1 plus t squared. All of this over v. V is this one. If I square this, the square root goes away. I remain with 1 plus t squared. So my dy now, dt is going to be equal to, this times this is 0. This is just be negative t over the square root of 1 plus t squared times, don't forget this guy here, it's just 1 over 1 plus t squared. So dy dt is equal to negative t over, huyu nikizidisha na huyu naweza nikamuingiza ndani. Nikimuingiza ndani huyu anakuwa ni squared, nikizidisha na huyu anakuwa ni cube. So it's just gonna be 1 plus t squared power 3. So this one is dy dt. Note it down. We're going to need it in order to get dy dx. Okay? Maybe I should repeat this part hapa kidogo. This is just negative t over, this is just 1 plus t squared, huyu hapa, na huyu nikimuingiza ndani anakuwa ni 1 plus t squared squared. Kwa nikizidisha huyu squared na huyu moja ndo napata hivi. Okay, just wanted to repeat that part there. So this one is dy dt, note it down, negative t over 1 plus t squared over the square root of 1 plus t squared per 3. So now let's find the x dt. So I have my x now equals to t over, this is 1 plus t squared. Again, this is a quotient, so I'll just let u equals to t, and v, I'm gonna let, and the v is just equal to the square root of 1 plus t squared. So now if I use the quotient rule, my dx dt is just gonna be equal to v, this is just du dt, minus u, this is just dv dt, over v squared. So u is equal to t. So du dt now is just going to be equal to what? To 1. If I differentiate this, I just get 1. So my v now is equal to the square root of 1 plus t squared. Hii ni kama ile v ya kule ambayo tulivyo differentiate tulipata nini? Tulipata t, hamna sababu ya kurudia njia ile ile. T 1 plus t squared. So now I use this quotient rule. Dx dt is just going to be equal to v. V is just the square root of 1 plus t squared times 1 minus u. U is just t. 1 is just du dt. T is just u times dv dt is just t over the square root of 1 plus t squared. All of this now over v squared is just 1 plus t squared. So my dx dt now is going to be equal to, okay, LCM hapo ni hiyo hapo 1 plus t squared. So nikigawanya na moja napata 1 plus t squared, nikizidisha na huyu napata huyo 1 plus t squared, okay? Minus t squared over 1 plus t squared. So this is what I have. So my dx dt nimesema ni sawa na 1 plus t squared minus t squared over the square root of 1 plus t squared times yule jamaa wa chini kabisa yule v squared, huyu hapa. So this and this they go, I remain as 1. So my dx dt now is just going to be equal to 1 over the square root of 1 plus t squared times 1 over 1 plus t squared. So my dx dt now is just going to be equal to 1 over the square root of 1 plus t squared power 3. This is my dx dt. So Now I want dy dx. I already said dy dx is just going to be equal to dy dt times dt dx. So I must find dt dx. So how do I get dt dx? Okay, hii hapa reciprocate. Kwa manake na hii pia lazima ni reciprocate. Inakuwa ni 1 plus t squared power 3. So this one is dt dx. Remember dy dt, I told you to note it down. So dy dx now is equal to, nimesema ni dy dt times dt dx. So dt dx tushaipata hii hapa 1 plus t squared power 3. Wakati dy dt tulisema ni ngapi? Ni negative t chini ya 1 plus t squared power 3. So dy dx ni sasa na nichukua hii dy dt over this one is 1 plus t squared power 3 times this one is 1 plus t squared power 3 here. So this and this go. So dy dx is just equal to negative t, hence proved. So remember the question was proving, yeah? So tumemaliza hiyo. So this is a last example in this subtopic of derivative of quotients of polynomials. Let me just say see you in the next tutorial.